So Matthew, everyone. Beginning with the math, we're going to start with the modulus, and what this does is it's a modified version of division. We use the percent sign instead of a slash for division, and with the modulus, what it does is it returns the remainder. It doesn't return the actual value of what's happened with it. So to run it, it's easier to see the result. So currently, the result of 0 modulus 10 is 0. So effectively 0 divided by 10, well, there's nothing there. So 1 divided by 10, we get a remainder of 1 out of it. So not the decimal remainder, but the actual whole remainder. The cool part about this, and we'll get to see what the pattern becomes with this, so 1 modulus 10, not 1 divided by 10, because 1 divided by 10 is 1/10. 1 divided by 2, or 2 divided by 10 would be 0.2, but here now, 1 modulus 10 gives me 1, 2, 3, 4, 5, 6, 7, and now the moment of truth is almost upon us. 9 modulus 10 is 9. 10 modulus 10. There is no remainder when you divide a number by itself. Therefore, the result of that is back to 0. Now if I go again, 11 modulus 10 is 1, 2, 3. So what you'll notice is the result of this math equation is effectively allowing me to do a looping count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 59 modulus 10 is 9, because 59 divided by 10 would be 5 with a remainder of 9. So the modulus allows us to keep the remainder as a whole number, not as a fractional representation. It keeps that whole number. That's what it does. But the usefulness is that with that simple equation, so we're saying my result is equal to my counter, which is going up every time I click the mouse. There's my counter, 59. Modulus 10. So it allows me to create a basic looping amount. If I wanted to loop not based on 7s or 10s, but if I wanted to do it based on 7, if we change it, we'll see we can change it. So it's doing division, where I get to keep the remainder. So 6 modulus 7, 6 divided by 7 is 0, remainder 6. 7 modulus 7 is 1, remainder 0, therefore I'm getting the 0. 8 modulus 7, 7 goes into 8 one time, and I have a remainder of 1. 7 goes into 9 one time, I have a remainder of 2. Then we get up to 14. 7 goes into 14 two times, remainder 0. 7 goes into 15 two times, remainder 1. So it's giving us a pattern. Moving on to the next topic, it's going to be random. We've used random a little bit before. Just going to review. Random returns a value. It returns a float between 0 and up to, but not including the value that you provide to it. And you can do a minimum and maximum in processing if you're so inclined. And let's see, this particular sketch is going to draw a line, and it will be then connecting the line to random points. So it creates this.
It's an earthquake.
So this is your heartbeat when I mentioned that we were doing math today. And we're trying to have you have a more happy heartbeat, and we'll work towards it. But we can see the math, the random function here. It returns a value. So each frame, it's updating that y amount to a random number between 0 and up to, but not including 200. Then it's adding 100 to it just to move it further down on screen, so that I I'm not drawing across the top of my monitor. But we're going to compare random. So we've used it before, and it's just, it returns that random amount between 0 and the amount I plug in here. Now, we're going to contrast that here with this. So now if you look at this line here, you'll see that this line is moving. Now, every time I click, it resets my x to 0, and then it continues on. So what you will notice is at that height right there, I'll put my cursor here, my line will pick up from this point and continue on. So now we're using the noise function. And you can see how noise is a much less aggressive entity than using random. So when you're trying to construct something that has some variety to it, and we've used random color, if you were to use noise instead, you don't get quite as much variety. And I've put the two together into a random noise combo here so that we can see them side by side and compare their differences. So you can see the one on the top is the student who is afraid of math, and the one on the bottom is the student who has embraced math as we were studying their heartbeat. So we can notice how it's a very different kind of experience. So random is really, it's just all over the board. It could be anywhere between 100 pixels above or below that red line. But what noise does is say, yeah, we could randomly move up or down, but we can only do so much at one time. So the change from our previous to our current is not going to be as dramatic. So it's a much more subdued kind of change. It also makes it seem much more real, so it's not so crazy or chaotic. Now if I click, it does the same thing where it redraws. You'll notice then that the noise picks up where it left off, so it's going to be right about this height here. And now it continues on. So noise is going to return a value. Here's a smaller one. It returns a value between 0 and 1. And then I multiply that noise value that I get back by the range I want the numbers to be. But what noise does is it's taking a value here. So each frame of my sketch, I feed my noise a value of 0.01. That gives me a number. The next time I feed it 0.02, and that gives me a number close to but not the same as the previous. Then I feed it 0.03, it gives me a number close to but not the same as the previous. Where random is just going to give me any number between 0 and 200. But here I'm getting a value between 0 and 1, and it's always going to be somewhat related. Could go up, it could go down, but it's not going to be a huge dramatic shift. Over time, we get to see a big shift in patterns, but not immediately. So if I just get rid of the plus here, so the value is always the same, when the line draws, I will now just get a horizontal line because it's now feeding the same value to my noise function. But if I run my sketch again, you'll notice it's not starting in the same place. So what it's doing is noise is going to take whatever you have, and then it's going to, out of its pool of starting points, choose where to begin. But noise effectively is just a long array of numbers, and it just kind of is grabbing those numbers and working with them and then affecting them by an equation. Now, noise is used in visual effects programming extensively for creating clouds, creating water, creating textures on surfaces. So computer-generated noise is used to make the realistic quality that we see in most movie special effects and visual effects that make things look natural and look like they're part of the real world, because it creates what appears to be a random distribution of numbers. But the good part about it is it's possible to then feed a seed into the noise function. So we can feed a seed value so it will always start with the same starting value if we so choose. So it's a very powerful operation on the computer. It won someone a Technical Academy Award. Ken Perlin made it, and the equation of noise is more specifically referred to as Perlin noise, P-E-R-L-I-N. So it's just a very popular and common thing for generating textures for 3D animation, for computer graphics, for creating atmospheric effects. We use it because it creates a pseudo-random experience. But it's arguably going to be a much better experience than the widely varied and widely kind of chaotic view that you get with noise, or with random. So with this new file, let's say it drew a rectangle on screen. Now, if I use a command such as rotate, and if we remember that rotate takes radians as our unit of measure, and if I don't want to have to think in terms of radians, I can now plug a radians amount in. All right, yeah, so in so I can now feed to my rotate a amount in degrees, convert it to radians. So if I wanted to rotate this 45 degrees, we'll see that it's now rotated 45 degrees. I'm going to adjust my X position here a little bit more so we can actually see where this object is rotating. And you will see that it's now landing way off screen. If I don't rotate it, we can see that it is here. So my object, I have an X at 300, a Y at 100. So 300 is half my width. When I hit rotate, if I rotate 45 degrees, if I draw a circle from 0, 0 to this point, we'll see that it should be right about here. So if I reactivate rotate, we'll see that now it's right about here. So it's rotated that circle, or that rectangle, down. So the problem anytime we want to rotate is it's going to be rotating around the origin point of the document unless we move that starting point. So all these numbers that we use here, x, y, where we rotate from, that's all based on the top left corner of my document. So that's based on right here. So we said x of 300. Well, 300, put x in the middle. Y of 100, put it about here. Then I said rotate 45. So we rotate around eighth of a circle here, and it pulls it down to here. Now, the problem that we're running into is that everything is in relation to the top left or 0, 0 point in the document. Well, processing allows us to move that document registration point. So I can move that document registration point. And let's say I move that point 100, 100. going to turn off rotation for now. So previously, it drew my object at 300, y of 100. We can see now my object moved. So I'm going to draw a rectangle. I'm going to move my origin point. I'm going to draw a rectangle again. This is where we get to do a whole bunch of screw with your mind sort of activities here. So what translate is doing is translate, as we look at the code here, translate 100, 100. So we were here, because we said draw the box at x 300, y of 100. We were here. Translate said move our starting point that we're measuring from in and down 100. So to possibly make it even a little bit more, I'll draw a rectangle at 0, 0 with height. So that drew a rectangle, it's starting right here. But if that command is echoed after the translate, so we're saying draw at 0. I now move that 0. So what translate does is it moves the origin point that the program is using for referencing objects as it draws them on screen. So all of our x and y coordinates, effectively what we're doing is we're relocating 0, 0 to whatever that translated point is. That's the magic. I'm relocating 0, 0, in this case to 100, 100. So if I draw an object at 0, 0, or even at 10, 10, so it's not right on the other one, we'll see now this third and final rectangle, it says draw it at 10, 10. Well, 10, 10 without a translate is all the way up here. 10, 10 with a translate, because we moved 0, 0 to 100, 100, it's now over here. So translate is about moving our origin point that we're using from that point onward. Anytime translate appears inside a draw loop, when you get to the end, it's effectively forgotten. That's just one key thing to keep in mind. It forgets that it knew it. Because if you were to put it inside a conditional or inside a loop that doesn't run every single time, then the translate isn't necessarily going to run. So not a lot of, I can't think of any immediate uses for that, but that is just a point to keep in mind is once you say translate, it's not permanent. It just keeps doing it every frame. So translate is about moving our origin point, moving our registration point for our objects. By default, documents are translated so 0, 0, the top left corner, is where we reference the position of everything in relation to that point. So if I translate 0, 0, draw a rectangle at 0, 0, it's right there. But if I translate 100, it now moved that. I'm still drawing at 0, 0. And this is the part that kind of gets a little messy in the brain. Instead of trying to figure out within my entire canvas or within my entire document, what is the x and y? When I say rect or ellipse or position image, I can put everything at 0, 0. I just have to translate that registration point first. For normal movements, it doesn't matter. But what does matter is if I wanted to rotate things, because then it rotates, because I don't want to, when it's rotating, I don't want to be rotating around this top left corner. I want to rotate around this point, or rotate even around the middle of this box. I want to rotate around the middle of this rectangle, so I want to make this spin on the middle of my screen around its center point. And we can do that. We can rotate that object. First step would be to move our origin point to the middle of the screen. So if I translate to width half and height half, before we draw this rectangle, I'm going to put a little dot there. Change my fill color to red. I'll draw an ellipse at 0, 0, 10, 10. So I said draw an ellipse at 0, but if you notice, it's now in the middle of my document. Because I moved my document registration point from the corner, I moved it to right here. Now that that's occurred, I'm going to look at our rectangle. Oh, forgot to uncomment it. So if I notice my rectangle, oh, want its fill to be different. So we can see the object is drawing from that top left corner. If I wanted my object not to be there but to be centered, well, I'm going to use theta up here. We'll start theta at 0. And then I will have theta go up by 0.1. So just a small increment. So now if we say rotate, we can see how the object is rotating, and notice it's rotating around the origin point of my document, which is currently there. Because I say rotate, then I moved that registration point. Okay, it's kind of cool looking, but it's not what I want. I want the box to spin in place. But if we rotate after we translate, we'll now see that the object is rotating in place.
Yeah, but something was not pulsing.
So if we think about the question of, I have two objects and they're rotating. Originally, I just said negative theta. If we imagine we've rotated the canvas our theta amount. Then if I say rotate negative theta, all that did was bring it back to 0 and it stopped rotation. But if I want the object to then rotate in an opposite direction, we need twice as much so that it counteracts it, though you have to use an actual number, not a symbol. Twice as much so that it now undoes the previous rotation and then rotates that same increment in the other direction. So then if I want my ellipse to not rotate, I believe that, so it doesn't pulsate, then we could rotate that back. Or yeah, just rotate back theta. And that will put it back to its starting position. So we should now see a non-pulsing circle. So now it's fixed. So it's not rotating anymore. Well, its rotation's being undone before it shows up on screen.
They kind of have like a deck of cards there.
So in the rotate to mouse example, to get the object to rotate around this angle. So if I turn off rotate, and if I turn off translate, we'll see that this document, when it loads, it draws a rectangle in the top left corner. If I were to then change its x and y to put it in the middle so it can draw and move from the middle, it would calculate the angle okay, it would draw it okay, but the moment I try and rotate the object, it's going to be rotating around top left corner of the document, causing all kinds of weirdness. So that's not going to work very well. So if I change this to x and y, let's see, here's the object, and now it's drawing in the middle. But if I rotate, you can see it's rotating based on the angle from my mouse to 0, 0. So it's not behaving. So we need, this is why in the rotation we needed to change that position. So translate its location and then rotate about that middle part of the screen and then just draw it at 0. And if it's drawn at 0, 0, you'll see that it's rotating around its top left corner using a negative half of its height. Its height is 20, and using -10 allows it to rotate freely.